This is Quick Clip 4.10, acceleration. And the most logical example of acceleration would be the acceleration of gravity. So if we have an object up on a tall building and it falls, it will go through an acceleration, meaning that it is going to go faster and faster as it falls. And the rate at which it increases speed is its acceleration. The acceleration of gravity is 9.8 meters per second per second. And that unit confuses a lot of students, where we have not two but three parts of the fraction, meters per second per second. What this means is that as it falls, it increases its velocity by 9.8 meters per second, and it does it every second. So after the first second, it has increased by 9.8, and then the next second it increased by another 9.8, and then the next second it increased by 9.8. So its acceleration is its velocity increasing per second. So 9.8 meters per second is the velocity that it's changing, and it changes that much every second. Let me show you how this works on a table. So here, again, acceleration is a change of velocity, and on the chart we start with time 0 at a 0 velocity, and then the object drops. After the first second, the velocity is 9.8. During the second, it increases by another 9.8, and now it's going at a velocity of 19.6 meters per second. During the third second, it increases by another 9.8, and so now its velocity is 29.4 meters per second. So you can see that it increased its velocity by 9.8 meters per second each second that it fell. So that's how we get that unit of meters per second per second. All right, so that's acceleration. And keep in mind that we could have a positive acceleration where something is going faster. We could also have a negative acceleration where the object is going slower, and often that's we use the term deceleration at times. And that brings us to Newton's second law, and the second law of acceleration is the formula force equals mass times acceleration. And so using that formula, we can determine the acceleration of a 20 kilogram cannonball shot with a force of 100 newtons. So we're trying to figure out the acceleration of that cannonball. The mass of the cannonball was 20 kilograms, and the cannon itself gave a force of 100 newtons. So using the formula F equals M times A, force equals mass times acceleration, we get 100 newtons equals 20 kilograms times acceleration. And doing the math, we have 100 divided by 20 is going to equal the acceleration, and we get an acceleration of 5 meters per second per second. And let's do one more example. Again, Newton's second law, F equals M times A. What force is needed to shoot a 0.2 kilogram arrow to an acceleration of 200 meters per second per second? So we know the mass, we know the acceleration, and we're trying to find the force. And there goes the arrow. So plugging it into the formula, we have force equals 0.2 kilograms times 200 meters per second. Multiplying that out, we end up with a force of 40 newtons. All right, I hope that helps for lesson 4.10.